Good morning. Good morning, everybody. Here, today's topic is, you can see, it is superluminal speed. What is the meaning of superluminal speed? That is the first question. Superluminal speed means speed which is faster than the speed of light is called superluminal speed. Speed which is faster than the speed of light, or speed which is greater than the speed of light, that is called superluminal velocity. Now, in this lecture, we are going to investigate theoretically that whether superluminal velocity is possible or not. Okay, according to Newtonian physics or according to Newtonian mechanics, both are same, there is no speed limit. Okay, there is no speed limit. If you consider the equation V is equal to U plus AT. You know this equation? Yes, using this equation we calculate what? Final velocity of an object. Here V is the final velocity, U is the initial velocity, A is the acceleration and T is the time. Okay. So suppose U has any value. Okay. Say U is equal to 1 lakh kilometer per second. Say U is equal to 1 lakh kilometer per second, means 1 into 10 to the power 5 kilometer per second. U is this much. And A has certain value. Okay. Suppose A is equal to 10 to the power 3 means what? 1000, right? 1000 meter per second square. This is the value of acceleration. And T, if you put different values of T, you will see that V will be, after some time, V will be greater than this velocity. 3 into 10 to the power 8 meter per second. Am I right or wrong? U is this much. 1 into 10 to the power 5 kilometer per second. A is this much. 10 to the power 3 meter per second square. And if you put suitable values of T, say T equal to 1000 second or 1 lakh second, etc. If you put that way, okay, then you will get some time, after putting a suitable value of T, you will get that V is more than this value. What is this value? We know that this value represents the velocity of light, speed of light. Okay, 3 into 10 to the power 8 meter per second. I have not written here kilometer. Yes, to write this in kilometer per second, result will be not power 8, result will be power 5. 3 into 10 to the power 5 kilometer per second. And say this is also kilometer per second. Okay. Then it will be easier to understand for you. Okay. Am I right? This is kilometer per second, this is kilometer per second square acceleration, and this is speed of light in kilometer per second. 3 into 10 to the power 5. So you know that by putting suitable values of T, you will see that V crosses this value. So according to Newtonian mechanics, this formula was obtained. V is equal to U plus AT. There was no speed limit. Yes, this is the maximum limit of any object. This limit cannot be crossed by anything. Such things were not mentioned in Newtonian mechanics. Now, in this lecture, in this video, we are going to investigate theoretically whether really this velocity is possible or not. This velocity means greater than this velocity. That is possible or not. And greater than this velocity is called what? Luminar speed. superluminal speed. So we are going to investigate whether whether superluminal velocity speed, whether superluminal speed is possible or not. Okay. So to investigate that thing theoretically, what we need to do, we have to do one thought experiment. We have to do one thought experiment. Say this is ground. Okay. And here there is one man, A. This is ground, horizontal ground. This is one man, A, man, standing here at this position. Here there is another man, B, standing somewhere here. And on the same line of AB, there is third man, C, standing somewhere here. Right? And suppose A throws a ball towards B. A throws a ball towards B with superluminal speed. A person at A, or the man at A position, throws a ball towards B with superluminal speed. Means speed which is greater than the speed of light. Right? Now what will happen? If this be the case, then what will happen? That is the question. So when he is throwing, this man is throwing ball in this direction. Okay, this is the direction. In this direction, when he is throwing the ball, okay, then from position A, light also will emit. Light rays will also emit. Okay, and we know that light is having the velocity c, small c. Okay, not this c. This represents, this capital C represents the man. C, and what is the velocity of the ball? Here the ball is there. Okay, velocity of ball is v, and we have assumed for this thought experiment that v is greater than c. Can you see clearly? Yeah, it is clear. So v is the speed of the ball with which it is being thrown towards B, and we have assumed that v is greater than c. Then what will happen? The ball will reach here to B. After some time, ball will reach here to B. Okay. So suppose when ball reaches to B, and since this velocity v is more than c, that means at the time when the ball was thrown, just thrown from A, both light and the ball was thrown simultaneously. Means when the ball was thrown, at that time light was also emitted from A. Right? But from A to B, it takes some time to reach the ball from A to B. It takes some time. So what will happen? Since B is more than C, then when the ball reaches to B, that light which was emitted at that time, at the time of throwing, that will be behind this ball. Means somewhere here. Say this is the position. Somewhere here. Light will reach here when the ball reaches to B. Am I right? Because C is less than V. So ball will first reach to B, and light will be just behind B. Behind the ball, not B. Behind the ball. Am I right? Now there is one observer C standing here. What he will observe, this man, what he will observe, that is the question. Now see, from here to here, this is the distance, and from here to here, this is the distance. So this distance is shorter and this distance is larger. This is longer distance, okay, and this is shorter. So obviously, when the ball reaches to B, light will be emitted from here and it will reach to C. Light is having a fixed speed, that is known to us. Light is having a fixed speed, and that speed is 3 into 10 to the power 8 meter per second. This speed is fixed, that is known to us. This speed is in vacuum, okay? In empty space, this is the speed of light. So, when the ball reaches to B, it takes up time to reach to C, and then only C can see the ball. Yes, he can see the he will see that ball has caught the ball. Okay, the person B has caught the ball. But here, from position A, light was also emitted. Now, which light will take less time to reach to C? Obviously, this one. So, when this light reaches here, this light means catching of the ball. This light reaches here. After that, this light will reach to C. Because this is larger distance and this is shorter distance. And when the ball reaches to B, okay, at that time the light was behind the ball. So somewhere here, we have assumed that somewhere here. So this distance, if you consider this distance is greater than this distance. Am I right or wrong? This distance is greater than this distance. So C is observing what? C is observing that this light reaches to here. Means what? He will observe, this man, he will observe that person at A has thrown the ball. That thing he will observe. And from here to here, when light reaches, this man will observe that the ball was caught by the person at B, located at B. That means he is observing catching of the ball first and then throwing of the ball. Is that possible? Is that really possible? You know cause and effect. We know that first there will be cause and due to that there will be effect. So, but here at the location C, this observer is observing that what he is observing? Effect first and then the cause. Am I right? He is first observing the effect and then he is observing the cause, and that is not possible. That is not possible. So, what is the problem? Problem was in our assumption that B is greater than C. That was our problem. That means B cannot be greater than C. That means superluminal speed is not possible. Am I right? Just by watching my lecture, you cannot understand this. You have to make your own thought experiment. Okay? You have to make your own thought experiment, then only you will be able to understand this lecture. So, superluminal speed is not possible. And this is the requirement, this knowledge is the requirement to study special theory of relativity of Einstein. Okay, Einstein's special theory of relativity requires this knowledge that superluminal speed is not possible. Okay, so this was all about this topic. Okay, next I will move to another topic from the same chapter. So this is the end of this video. Thank you. Thank you for watching this video.